Hi there, how are you today? I hope you are doing well. Okay, let's start our lesson today. Revision. Unit 1, Force and Motion. This unit consists of two lessons, types of levers. This is the previous lessons. And now, law of levers. This is the second lesson in this unit. Look at these children on the seesaw. Nearly, they have the same weight, that affected by the same forces in both sides of seesaw. And the other image, the boy and his mom on a seesaw. I'm sure in weight the difference between them is very large. This seesaw is an example of lever, resistance force, effort force, and fulcrum. And this is a lever is first type lever because the fulcrum between resistance force and effort force. Okay, seesaw is a first class lever because the fulcrum between effort force and resistance. And so some types of lever can increase the force. Okay, in this lesson we will learn how this boy can increase his force or weight to equilibrate his mom's weight by changing the place of fulcrum. Okay, let's start the lesson. Let's go. Okay, law of lever is a mathematical equation that explains the relation between effort force and resistance. This equation, effort force times its arm equal resistance force times its arm. Oh, mister, what's meant by effort force and its arm, resistance force and its arm? Okay, effort force, this is the force that try to equilibrate the resistance. Okay, and its arm, effort force arm, it is the distance between the effort force and fulcrum. Resistance force, it's the resistance effect to the lever by its weight. Resistance arm, it's the distance between the resistance force and fulcrum. Don't forget each distance with the same unit: meter, centimeter, kilometer. The resistance arm in centimeter, force arm should be converted to centimeter. Effort force arm in kilometer, the resistance arm in kilometer. Okay, this is very important, and this equation doesn't be applied if the lever isn't in the balanced state. Okay, the lever should be in the balanced state. Okay, this equation apply. This is the first example to know how to apply law of lever without numbers. Okay, this wheelbarrow. Okay, the effort force, the place where we hold it, the effort force arm, distance between effort force and the fulcrum, and it is the point in the center of wheel. Resistance is the load. Here the load is a very large piece of stone. Okay, resistance arm, the distance between resistance force and fulcrum. This very easy example. The problem here to determine the resistance force, effort force, resistance arm, effort force arm, and fulcrum. Don't forget resistance arm and effort force arm in the same unit to apply the law. Again, effort force times its arm equal resistance force times its arm. The factors that determine the values of force and resistance are the force arm and resistance arm. When the force arm and the resistance arm are equal, the distance from effort force to the fulcrum equal the distance from resistance force to the fulcrum. The effort force is equal to the resistance force, and this lever doesn't conserve effort because the distance from the resistance force to the fulcrum equal the distance from effort force to the fulcrum. And when you applied the law of levers, effort force times its arm equal resistance force times its arm. We will apply this in the next slide. Now in this slide we will answer the same question with a different way. The first one a wrong way and the right way. Keep attention. Okay. First type, effort force times its arm. Effort force times its arm. Okay, effort force equals 60 times its arm, 0.9 meter. Okay, equal 54. Resistance times resistance force times its arm, 60 times. Here we will change here 0.9 to centimeter and write here centimeter. This one is by meter, and the other one by centimeter. The result actually comes wrong. On the other side, effort force times its arm equal resistance force times its arm. 60 times 0.9 equal 54. 60 times 0.9 equal 54. This is a right answer and this is a wrong answer. Don't forget that the resistance arm and the force arm in the same measurement unit. Okay, when the force arm is longer than the resistance arm, the effort force is smaller than the resistance force, and this lever conserves effort. For example, not a cracker. The distance from effort force to fulcrum is larger than the distance from fulcrum to resistance force. Okay, so this lever conserve effort. And the other one, wheelbarrow, the effort force to the fulcrum larger than the resistance arm to the fulcrum. Both conserve effort. Okay, this is the last case. When the force arm is shorter than the resistance arm, the effort force is larger than the resistance force. And this lever doesn't conserve effort, but has other benefits, such as avoid dangers, accuracy in performance. For example, coal tongs and the tweezers. In this example, ice holder, the distance from O, fulcrum, to effort force is shorter than the distance from fulcrum to resistance force. This example and this lever doesn't conserve effort but avoid dangers. Now we'll determine the possibilities of the three types of levers. First class levers. There are three possibilities in this type of lever, which are: first, the force arm is equal to the resistance arm. The effort force is equal to the resistance force. This case doesn't save effort. Second, the force arm is longer than the resistance arm. The effort force is smaller than the resistance force. This case saves effort. Third, the force arm is shorter than the resistance arm. The effort force is longer than the resistance force. This case doesn't save effort. Second class levers. The force arm is always longer than the resistance arm because the resistance between fulcrum and effort force. This type of levers always save effort. Third class levers. The force arm is always shorter than the resistance arm because the effort force is between the fulcrum and resistance. The effort force is always longer than the resistance force. This type of lever doesn't always save effort. Try to answer the two questions and send them to me. See you later. Goodbye.